In this video, we're going to talk about the HTTP receiver that is a new feature in the network services component in EventSentry. Now, the more common name other products refer to this feature is HEC, the HTTP Event Collector, which allows you to receive logs from remote devices in JSON format via the HTTPS protocol. Configuring the HTTP receiver in EventSentry is fairly straightforward. You will first enable the feature, of course, with the checkbox and decide on a TLS port that you want to use. And then you want to create at least one authorization key and token that you will give to the remote device that will use at the remote device to authorize it to send logs to EventSentry. And it's generally recommended that you use unique keys, at least for the type of device, for each different type of device that's going to be sending the logs, because that will allow you to assign different log types to those devices. Then we'll have a temporary file name. So how this feature works is once the data has been received by the HTTP receiver, the data will be stored in a temporary file that is then picked up by the EventSentry agent. And this works similar to how the Azure logs are working, which is explained in another video. The default file name usually works pretty well. It stores files in the temp subdirectory of the agent directory, but of course you can change that. And you can see that it stores the authorization ID, so that's this column here, the IP address from which the data has been sent, and then a timestamp on top of that. So that lets you more or less uniquely identify data sent from a remote device. You can double click on this entry here, and you will see that the auth token was copied to the clipboard. So we can go into the editor here, say paste, and now we'll see that information right here. And you can, if you hit the plus button, it will simply create a new random authorization token and ID, and you can remove it again. There's currently no way to edit this, so you'll have to create them with the plus and minus buttons. On the remote device that will be sending the logs, you'll usually just need the hostname or IP address of the EventSentry server along with the port, of course, the TLS port, and then the authorization token. And once you provide that, the device should be sending all the logs in JSON format to this IP address or to the EventSentry server. Now, just enabling the HTTP receiver is not going to be enough to actually see the logs in the web reports. And that's why we have that log files and definitions button here that brings you straight to the log file definitions that are important to understand here. In this example, as you can see down here, I'm using a daemon called FluentBit on a Linux machine to send JSON logs to this EventSentry server to illustrate how we can set up log file definitions and how we can actually get that data into the web reports. So when the Linux machine sends, I'm going to remove this here again, sends its logs in JSON format, is actually the same as syslog. So we could just send the syslogs here, but this is obviously for this training video. It will look like this. And this is basically a bunch of JSON fields all in an array. And I extracted one that is a little bit more verbose and descriptive. And here we can see that we're getting some metadata along with the log data. So the actual log string here is just this here. So normally if you get a syslog message with the same, it would just be this. So there's a bunch of metadata here included that we may or may not use. So that's kind of up to you as the person who's configuring these log definitions. In our case, we are going to be taking advantage of a couple of them. But again, other devices will have a completely different format, completely different data. But let's start taking a look at how would we decipher this, how would we get from here, from this JSON to, and I'm going to show this right here, to this information here where we have the priority, the facility, the sender, along with the actual message from syslog. And the process is pretty straightforward. So we'll start right here with a log file definition. So if we go down here, we'll see that I already created this definition here. We can see that we have 4 fields mapped. I'm going to double click that. And here are the fields that we're extracting from this JSON message. We're starting at the top with just with a descriptive name so we know how to refer to this. So this is just called Linux. And then we can basically just go step by step. So the first one that we're interested in is the priority field. So if we double click this, we'll see, okay, this is an integer, clearly. Both the priority and the syslog facility are integers. And we're mapping it to a JSON field called priority. So if we look here, then we will see, oh yeah, this is priority. And we can also see the number 6. Now the number 6 here is in quotes, so it's actually transmitted as text. And that's the main reason why here it's important to select string and not integer. Going to the second one follows the same pattern. So now we're essentially defining it as an integer. We can see that number 1 here is no longer available because it's used by the other one. These are single-use field types. Once you use them in one field, you cannot use them in another one. Here, again, syslog facility, just like it's shown right here. And string again, since it is a string. So then it gets a little more interesting. So the next thing that we're using is the host name. So here we're using a lookup text, and we're pointing it to the underscore hostname field. So if we look down here, we'll see, okay, here's the underscore hostname, and it's a string, of course, and we're using a lookup text. So lookup texts are used for data that's repetitive. So if you expect that this data is going to show up repeatedly, rather than storing it over and over again, we can actually use this lookup text functionality that will just store the actual text, the actual hostname one time, and then sort of use only store the numerical values that will reference this field. So this is only useful for data that repeats often. For unique data, such as log data, you would not want to use this because it would overwhelm the lookup tables. And that's why down here, now we're looking at the message field, so that's the one down here. Again, this has to match 1-to-1 without the quotes. And here we're saying, okay, this is actually just regular text, max 1024 characters. And that's it. So that's the definition of this. And we, of course, have to check convert from JSON. So that's important. And that's all there is. So now we have a definition ready here that we can use. So after having the definition, we need to tell the EventSentry agent, well, where are these logs? So the definition is great. It defines that log file, but that's all it does. So we now need to tell EventSentry, well, where are these logs in this format? Where are they coming from? So now let's take a look here. So here we have a log file. I'm going to double click that. Again, just a descriptive name. We're telling it what the type of this log file is. So this is Linux. The line separator is Windows because, of course, everything here is happening on a Windows host. And here we essentially have the same path that we've seen earlier. So if we click on HTTP receiver here, then here we have the same path with one exception, that we are using the alt ID here directly in the log file. So if I go back to the log files and definitions here, wrong one, then we'll see that I hard-coded that authentication ID in the file name so that the agent will only look at files that are coming in this format from this with the security token and map them to the Linux format, because you may have another sender that's sending a completely different file type. Well, then you will have to create a second definition here with the same path but with a different authentication ID. Otherwise, you'll have problems mapping those different JSON types to an EventSentry definition. If you only have one device sending in the same format, then it doesn't matter. You could just omit this and just say network service http_start.json. But if you have multiple ones, then you'll want to include that ID here. So that was the second to the last step. There's one more step required now. So now the HTTP receiver is ready. It's receiving logs. We have a definition that we've mapped to an actual file, so the agent knows, okay, these files are to be expected to be in this format. And now we need to tell EventSentry, well, what do we want to do with this if you do encounter it? So for this purpose, we have a package. The package is assigned to this computer here. So we're not assigning this to remote computers. We're assigning it to this computer. So we have a new package. So if we look at assigning here, we'll see that it's just assigned to the EventSentry machine. And then we added a definition. So we say add log file. And of course, the one that we have, the Linux one, is not listed here because it's already here. Here it shows us again what's the log definitions, where are these files, and now we have a little bit more information. And now we're telling EventSentry, okay, well, what do we want to do with this? Do we want to write it to a database, or do we want to create event log alerts? I did not set up any alerts here. Instead, I told EventSentry, well, let's just write it all to the primary database with 3 exceptions, because there's some data that I don't want in there because it's just not relevant. So we selected the first option, include, log all lines to the database except for exclusions below. So we got these 3 things in here that are very repetitive. They're just kind of polluting the logs. We don't want that. So these are exclusions. And that's all there is to it. Here, of course, I filtered this out. But if I were to take that filter and reset it and just go with the regular logs here, then we'll have a little more information here. But that's essentially what this looks like. We now have logs coming from these Linux machines. They're properly being mapped to the EventSentry log file, and they can be viewed here along other delimited log files, right? So we have delimited log files possibly from DHCP, from Radius, maybe from Azure, DNS. But here we simply select the definition, and we'll see the logs that came in through the network services HTTP receiver. Now, just a quick recap to reiterate how the flow of data works. So data is first received by the HTTP receiver, and it's stored in these file names here, dynamic file names. Then we're telling EventSentry by clicking on log files and definitions. This is also accessible here, by the way. We're telling EventSentry, well, what type of JSON logs are we expecting? So we're creating the definitions here, and in our case, just 1. And then we're telling EventSentry, well, these files, these definitions are in these files. And that allows us to assign different types of log file definitions with different file names, if necessary. So now EventSentry knows, okay, we have these JSON logs coming into this file name in this format. And then we simply create a package, assign the log file that we've created here, and tell EventSentry what we want to do with it. In most cases, you just want to write it to a database. So then we just add the database. We provide any exclusions that we want. This can also go the other way. We could say, well, we want to exclude everything and only log specific data to the database. But in most cases, you'll want to just exclude a noisy text from the database. And that's it. When starting to implement this, the first thing I would recommend is take a look at the JSON data, figure out, okay, how do you want to map these? Which fields are you interested in? Nesting is supported as well. I'd recommend watching the Azure video for that, for the cloud logs. And then create the definition, enable the feature, and then essentially just create the log file along with the package to then store this data in the database. As always, thanks for watching.